So today is the 15th day of the LeetCode 30-day challenge, and I will try to explain my thought on my iPad so I can use my Apple Pencil to further explain the approach more clear. So let's go. The problem is we are given an array and we want to calculate the product value except at position I. For example, at position 0, the answer will be 24 because 24 is the product value of 2 times 3 times 4, and so on and so forth for the followings. And there are two approaches for this problem. The first approach will be using the linear space complexity. So we are going to use the linear time and linear space solution. And that will be, we build a prefix product and a suffix product for the array, and each time we are at a certain position, we query the left and right. We query the prefix times the suffix to get the product of element except self. And for example, then the prefix will be 1, 2, 6, and 24, and the suffix will be, okay, I should use the other color to differentiate. Prefix will be 1, 2, 6, 24, and the suffix will be 4, 12, 24, 24. Let's see, 1, 2, 3, 6, 24, 4, 12, 24, 24. Yep. And the answer, which is the result, will be at the first element, we only query the suffix, which is 24 here. And at the second element, or at position 1, we query these two, which is 12. And at the third element, or say position 2, we query these two, which is A. And at the last element, we query the prefix, the second last element of prefix, which is 6. The following will be the first implementation, which is in linear time complexity and linear space complexity. Here we build the prefix product array. And prefix equals to 8. Okay, A still times 2 nums I, suffix I equals to A. Build result. If it is the first element, then will simply be a suffix I plus 1. The last element, prefix I minus 1. big size times 6 plus 1. Okay, run some edge cases to see if this works. Send the solution. Okay, now we are going to the second approach, and I will cut them as to video. The second approach to this problem with linear time complexity and constant space complexity. The solution will be very similar to the first approach, but we will not directly build a prefix and suffix array. We only lead the output result array. Why? Because we can first initialize the result array as the prefix array, prefix product. And then at the second step, we iterated from the last element of array to the first element. So how do we approach this? If the current element, or say the position, is equal to n-1, where n is the size of array, then the result will be will be the second last element in it, and else if the position is at 0, then the result will be right. So what is right? The right is simply just the suffix product, and at here the suffix product will be first initialized as 1 and then gradually grows as we move from right to left, or simply from the last element to the first element. So the right, I will use the yellow color as right variable, the variable as right, or right variable named as right. Right here is 4, 12, 24, 24, and we will still get the final result. Else, for the element that is neither the first nor last, then the element will be right, where now right will be served as the suffix product, and the result i-1 is simply the prefix product, which is same as the aforementioned this one, and now right is this one. Okay, the following I will do the code implementation of the second approach, which is in linear time complexity and constant space complexity. Thank you. Here is the code for the second approach, which is runs in linear time complexity and constant space complexity. So we will first initialize some variable and initialize the result array as the prefix product array, which will be done here. And then we simply build the result. But now we will do from right to left because we now lack the suffix product. And here, the suffix I plus 1 will be simply replaced by suffix, which is the suffix product. And prefix I minus 1 will be result because we first initialize the result as a prefix product array. And then here, the suffix will be multiplied by this non sign. And so for this one. Let's see if this works. Okay, submitted answer. Okay, so now this is the second approach, which runs in time, linear time, and constant space. Thank you for joining today's video. Thank you. Bye bye. Bye bye.